I've got my phone plugged into a battery, so with any luck, I'll be able to do this for a while. Do you know, something that struck me, well, there's a bunch of things I want to talk about, but the first thing that, you'll have to excuse me, this bit's very loud, unconscionably loud. Mind you, you need that sort of wrapping to keep the kerosene smell out, or paraffin as we used to call it in this country before we got Americanised. Yes, I know, paraffin and kerosene are two slightly different things, you know. One's got like... Actually, are they different? If you know any difference between paraffin and kerosene, let me know. Because as far as I know, they are the same substance. And I do remember I used to be able to go to a petrol station and I was able to order paraffin, which is useful for stripping paints and stuff. Anyway, did you know in France they pay a flat rate of 14 cents per kilowatt hour for electricity? Which makes sense because in France they have nuclear power. The nuclear power produces electricity at a steady state all day round, regardless of that. Most countries, which aren't forward thinking, they have power that comes on demand. And so during times of high demand, the electricity costs are greater than times of low demand. But France doesn't do that. France just has a flat rate of 14 cents. Now, I don't know if companies pay a higher rate, because I know electricity costs for domestic and commercial are different in this country, but they do in France. And the reason it struck me as odd is I thought, my God, 14 cents per kilowatt hour, that's cheap. You could heat a house with electric for that, and many houses in France do. But there's still a lot of houses in France which use wood and coal to heat the houses. In fact, there's even some that use diesel or gas. And the funny thing about that is, a lot of my family, they live in Belgium, but right next to the French border. And that's where you see a lot of windmills. And I laugh whenever I see them, because I just think to myself, that is just a virtue signal. You're saying, oh, look how forward-thinking we are with our bird-killing machines that make balsa wood an endangered species. I'm not opposed to windmills as a concept, but I am opposed to killing birds and logging balsa to the point that it's being illegally harvested and it's endangering its status. So anyway, France, 14 cents a kilowatt hour. And my relatives that live in France, they have, well, one of them, not only does he have a log stove, he also, which is one of these weird sort of 21st century, I say weird 21st century one, it has a ventilation control, which is a motor. And when you turn it up, the motors, well, there's kind of two. There's one which forces air in, so like forced induction. But then there's also another one which there's like a heat exchange element at the top, and it blows air out through vents. Which, again, you know, there's probably arguments to be said, oh, here's the efficiency graph of you know, using this forced induction system, and it's in France, so if you're paying 14 cents per kilowatt hour, having a motor going at 10 watts is hardly anything. But, and also it sort of goes in with the theme of the house. It's modern and, you know, it's nice. But I keep thinking to myself, the old way of doing it, which is, by the way, not this way, But the old way of doing it, where you have a stove made out of bricks, and in some cases not even bricks, you just have clay and sand or rubble. And the idea is that whilst bricks are a poor conductor of heat, they do retain it for a long time. So you can use a few logs to heat up your house during the day, and then during the night, or actually for the next 16 hours, you're going to have heat dissipating from the bricks. Now, I say this is modern, for example, because in the past 200 or so years, when cast iron and steel were mass produced, because now you can have a small stove which puts out a lot of heat, and you don't need to build bricks, and you don't need a specialist mason who understands the thermal coefficient and expansion of bricks, and which is why I always think it's surely just be easier if you make a so you see, this has got ceramic in it, and at some point I promised myself I will replace it, because look, I've got a broken one over there. So that what's the idea of that? Is it to all I can think is the reason that there's those tiles in there is to reflect the heat back and then sort of push it out through the window, which I really ought to clean at some point, because when you clean the window, more heat comes out. But the heat comes out eventually through the sides and the top anyway. It just takes longer and it's not sufficient. So yeah, there's an argument to be made for that. Is there an argument to be made for... there's probably an argument to be made for nuclear power, because I'd like to pay 14 cents now. In this country and most countries, it's... Well, I can't even tell you what the cost of a kilowatt hour is, because it's like going to a Middle Eastern bazaar, and it really depends on how you haggle it. And the cost changes every hour, if not every minute or second. No, it'd be far simpler to just have it the way the French do, and just go, we're having nuclear power. I know some cynics will say, oh, but don't you understand, electricity is just a nice bonus, a PR event. The real reason France has the nuclear reactors is to produce plutonium to make their nuclear deterrent. And yeah, but it still doesn't... That's still a benefit to the French people. I mean, they managed to deter any Russian aggression, and they've... what's the other word I'm looking for? Their people have benefited from cheap electricity, which, I mean, I don't know what industry is like in various countries. I know a lot of people say that Germany's got the best industry, although recently that's changed because they no longer have access to cheap electricity because of natural gas, which it's not just about the electricity, it's also about the fact that from natural gas you can produce all sorts of useful chemical products, including artificial fertilizer. And due to current events, that's no longer a position. But that said, France has got abundant cheap electricity, and you can produce, using electricity, a whole slew of useful chemical products just from I'm going to get this word right eventually. Electrolysis of water. There is another term for it, but I can't pronounce it. Electrolyzing. And also from just taking the air and then applying a lot of heat to it in the form of electricity. You do that in an an arc reactor. You make a great big spark of lightning, and you get all sorts of interesting chemicals just from air. One of the products you get probably be nitrous oxide, which is undesirable. But with a bit of energy, you can turn that nitrous oxide back into nitrogen and oxygen again. So it's That's the thing about chemistry. Every reaction is reversible. You never end up with a compound and go, oh, well, it's formed that compound now. There's no chance that it can ever unform that compound. The only the only things which are unreversible, and even then, I think if you use enough energy, you could probably reverse it, is when you have nuclear decay and you have all these radioactive substances eventually turning into an isotope of lead. But I mean, if you put some lead into a particle accelerator and bombard it with neutrons and protons, you will end up with different elements. Now, that's it. You put in different protons into something, and you end up with a new. I'm having to think very carefully on this because I'm just thinking, well, what's helium and what's tritium? Right. I'm going to go say this, and again, please correct me if I'm wrong. You put more protons into an element, you end up with a new, heavier element. You put neutrons into an element, you end up with a heavier isotope. And I believe at a certain point, when you've made a new heavier element, you have to put neutrons into it, otherwise it's just too unstable and it immediately decays back into its previous form. So the neutrons are there to act as a balance. I could be wrong on this. If I am wrong on this, please correct me in the comments because I'd like to know. But yeah, cheap energy. And the other nice thing about cheap energy, because a lot of people could say, oh, well, yeah, you know, I live in France and, you know, you could heat the house cheaply with electricity, but it is nice to have a proper fire. And I'd say, well, yeah, a proper fire has got nice things to it. I mean, the smell. I quite like the smell of birch when it's burning. A lot of people like the smell of oak when it burns. But the main benefit of fire, I would say, is heat in the form of infrared radiation, and you can do that with infrared bulbs. It feels absolutely wonderful being under an infrared lamp. And in fact, the closest thing to an infrared lamp is the sun. And everyone agrees, unless there's something significantly wrong with them, that it's nice to be out in the sun. I right now, in the middle of February, where it's midday and it's as dark as twilight out there, I would like to be in the sun, have it shining on my cheeks and on my back. That's the cheeks on my face for you. Don't get vulgar. I would quite like that. I think that would be really nice to have some sun and just go into my bones and make all the joints not stiff again. That would be really nice. And you can do it with an infrared lamp. And in fact, I've got one upstairs. So if it wasn't for the fact that I have this on most of the day, I would be in front of that infrared lamp. Yep. Infrared radiation, it's good for you. You should get some. That's it really. 14 cents a kilowatt hour. How much do you pay for electricity? And is it like going into a Middle Eastern bazaar where you have to haggle with the merchant and they'll say, oh, well, at this hour I can offer it for this rate, but at this hour I'll offer it for this rate? Did you know, and I don't know if this is true or not, but I've been told that during night time in the UK, because of so much power being produced by wind, I think it's anywhere from 10 to 15 gigawatts, depending on, it's anywhere from 0 to 15 gigawatts. It really depends on how much wind we're getting, and sometimes we don't get the wind. But if there's very low demand and there's all this wind power being produced, you either have to shut the windmills down or... I know I keep calling them windmills. Or you pay people to have the electric. So sometimes the actual rate for electricity is a minus amount. So if you're using a kilowatt hour, they'll pay you 4 pence or something. And The idea being is you can encourage people with electric vehicles to say, oh, well, if you charge it during this time, we'll actually pay you to do that because you're helping balance the load. And because the last thing you want to do is to change the frequency. You want to keep it ideally at 50 hertz. Or if you're in one of those places that listen to Tesla, you keep it at 60 hertz. In fact, why do we even do that anymore? We got all these modern things. Why can't we just say, well, you know what? It'd be ideal if we had 600 hertz, and we've got the machines to do it now. I suppose it's just too much legacy equipment. Like some people could argue, changing the sockets or changing the supply so you'd have a. I've said this before, but I'll say it again. I think it would be a good idea in every domestic household and probably some commercial ones as well. If you have your 240-volt mains in, and that's alternating current, but then you have a high efficiency switch mode power supply, something in excess of 90%. The one on my computer is about 96% efficient, but that's because I chose that as a power supply that's 96% efficient means that only 4% of that will be turned into heat. But something in excess of 90% efficiency wouldn't be too hard to make, and that could give out 48 volts DC. And the reason I say 48 volts is you can do a lot of useful work with that. Could you power a washing machine motor with 48 volts? Don't know. And then all of your electronic appliances like televisions, computers, and chargers for your phone, that you could just use a DC to DC converter and turn it down into your 12 or 5 volts respectively. And then for your high intensity applications like toasters, kettles, and ovens, you'd still have that directly connected to the AC because there's no loss in those devices. I mean, kettle, toaster, and oven, they're all 100% efficient. They're designed to turn electricity into heat, and that's what they do with 100% efficiency. Again, please put in the comments if I'm wrong and say, oh, actually, no, an oven's only 96% efficient, and if it's a fan oven, it's this percent efficient because you're spending electricity on the motor to turn the air on, circulate it. I would be quite happy to discuss energy and how it's used. But the point being about that, legacy applications, right, why don't we have a 600 hertz supply? And the reason I say that is because it'd be 10 times better than a 60 hertz supply. And what do I base that on? I base it on the fact that in aircraft, they use high frequency alternating current. I think it might be 400 hertz, but maybe different aircraft have different frequencies. And the reason for that, with alternating current, if you have high frequency alternating current, the thickness and therefore weight of your wires can be reduced while still carrying the same amount of power without having those wires overheating. So we could have efficiency gains if we do that. We'll probably come to some sort of hybrid solution. I mean, there's already high voltage direct current links between various countries. We have, I think we have 3 or 4 links between France and the UK. And one of those links, because we used to have a low voltage one, like 38,000 volts, and I think it only carried a few hundred kilowatts. There's now a 1.5 gigawatt link, and it's inside the surface tunnel of the Channel Tunnel. And I believe any sort of gigawatt range interconnect is high voltage direct current, because they found out, yes, direct current is inefficient, but when you make it really high voltage, and I don't know what that means, like 1,000,000 volts, 2 million volts, when you get to those sort of levels, it's more efficient over long distances than alternating current, even though you've got to have a converter at each end to turn it from AC back into DC and vice versa. But yeah, the Channel Tunnel provides electricity. That's nice. Oh, do I want to do one more bit or do I want to say goodbye? No, I'll do my bit about hydrogen in another video. Anyway, thanks for watching, and please do comment. Even if you don't know anything about electricity, just say, oh, I've watched to the end and I'm leaving a comment. Cheers.